Hey everyone, and welcome to AC Academy. Today we're going to be focusing on Algebra 1 section 2.1.4, and that's explaining exponential functions. All right, so let's go ahead and step into it. So let's take a look at question 1 right here. Sorry, let me get the pen ready. Okay, so question 1 states, if a student said that f of x equals 1,000 times 1.050 to the x shows how the balance in their savings account would change with time. What does the number 1,000 represent? Solve for the balance of their savings account for the first 5 years. Okay, so let's take a look at this question. So f of x here, and let me zoom in a little bit. Okay, f of x here equals, I'm writing this out since I couldn't type it, 1.050 to the x power, right? So they're asking, what does this 1,000 number represent? And solve for the balance of the savings account for the first 5 years, right? So let's go ahead and make a table on this side. So we have x, and then we have f of x, or y, I guess, right? So we're going to do first 5 years. So initial 1, 2, 3, 4, 5. So first thing before, we could say the answer for what does 1,000 represent, but I think doing the table first will make more sense of the problem. Okay, so let's go ahead and solve for x equals 0, right? So let's zoom in over here. So whenever x equals 0, f of x equals 1,000 times 1.050 to the 0. So anything to the 0 power is equal to 1, right? That's a rule that hopefully you have memorized in class. But we have this number to the 0 power. So this is equal to 1, right? So this is the same thing as 1,000 times 1, which equals 1,000, right? So the initial balance of the student saving account at time equals 0, or the balance of the student savings account, at time equals 0 equals 1,000, right? And I just said it, so making sense of the problem, initially the student would start off with $1,000, right? They set up a savings account at time equals 0. They have $1,000 in it, and this would act as like the interest, right? So the 1,000, what does the number 1,000 represent? That represents the initial amount within the student's savings account. Okay, so at t equals 1, 1,000 times 1.050 to the 1 power. So this thing to the 1 power equals itself. So 1,000 times 1.050 equals 1050. Okay, now let's do this again. 1,000 times 1.050 to the second power, 1.050 squared times 1,000. This equals 1102.5, right? And that's year 2. Year 3, and then 1.050 to the third times 1,000, 1157.63, and so on and so forth. I'll fill out these really fast just so you know what the setup looks like. And then writing these two out real fast. Right? Okay. So we solved both parts of the problem, right? The initial part was just making sense of the question, right? It's saying that if a student said this equation shows the balance in their savings account, how the balance would change with time, what does this initial value represent? Since t equals 0, them setting up the savings account, so that means there has to be some initial money in it, right, to gain interest. This would be the initial money that they put in. as we see at t equals 0. So no time has passed. This is the amount in their savings account. Thus, that's the amount the student put in initially. Okay. Now, these two questions are related. If we're looking at question 2, let me zoom out slightly. Related in a sense that we can make sense of the problem. It says create an equation for the following table, right? We have a bunch of knowns, and then we have the equation being the unknown, right? So f of x, we're going to set it up at the same way this is. A equal, A equals some percentage, let's call that n to the x. Okay? So we know at t equals 0, so x equals 0. As we set up here, a is this value whenever t or x equals 0. So we know that a is going to be 0.0625. Okay, so rewriting the equation, 0.0625. I'm going to zoom in here since I have the general idea of this problem from the first problem. This is going to be times n to the x. Okay, so let's use this next one, right? Let's plug this in. So this value, 0.25, equals 0.0625 to the n x. Okay? How do we solve for n? First, let's isolate n. Okay. Let's divide this by 0.0625. Same thing on this side. And then 0.25. Calculate 0.25 divided by 0.0625. That's going to be 4. 4 equals n to the x. We know that x equals 1, right? So anything to the first power is n. So n to the first power is equal to n, right? So this is going to be, I'll put arrows there. 4 equals n to the first power, so 4 equals n, okay? So this equation, f of x equals 0.0625 times 4 to the x. And that is how you solve this problem. So again, if there's any confusing steps here, or if you have any individual problems that you'd like me to work out, go ahead and leave it in the comment section, and then I'll get to those as fast as possible. Overall, repeating the process, kind of a few things you have to know. What you have to make sense of the problem. So we know that at x or at t equals 0, that a value is the amount, is your initial amount, right? Whether you're doing like half-life decay or savings, interest, whatever it is, that initial amount at t equals 0 is that a value, right? You also have to know a number to the first power is itself. So referring to the second question, we had 4 equals n to the first power. So that means 4 is equal to n. All right? So if you understand those things, then these problems should be pretty straightforward to solve, unless there's not a 1 here, or if you go to 2 here, then you use other methods to solve them, which I will show in a later chapter. But anyway, again, if you have questions, go ahead, put them in the comment section, and I'll get to them as soon as possible. Thanks, and see y'all in the next video.